Hi, my name is Wong Ke and my metric number is B0621100492. Today we want to talk about what is hybrid manufacturing. Hybrid manufacturing is a manufacturing process where additive manufacturing and conventional subtractive manufacturing technologies are combined and used together within a single setup to create a part. Both processes on their own have remarkable capabilities, but when they combine, it opens a whole new level of design and manufacturing. With hybrid, it is also possible to combine materials during the process and apply different metals to the same part. Nearly any metal is available in both wire or powder format for additive manufacturing. By using different metals in a single part, you can get the best attributes of both parts without compromising the integrity of the part. There are two types of hybrid machines. The first type of hybrid machines is an off-the-shelf hybrid machine offering both additive manufacturing and subtractive, while the second is to add additive manufacturing capabilities to a subtractive machine. Although the overall number of available hybrid machines is still relatively small, it is a technology that is only going to expand and grow because of the capability to combine both processes into one. There are three industries that use manufacturing, which are medical, aerospace, and automotive. In medical industry, you can create implants and prosthetics using hybrid machine. Custom-fit device can be created using 3D printing, for example, and then finalized via detail milling and polishing on the CNC machine. The aerospace industry requires complex, lightweight, but strong parts, making hybrid manufacturing essential to the industry. Aerospace companies were some of the first to adopt additive manufacturing. Engineers designing and manufacturing for commercial and military aerospace platforms need flight-worthy components made from high-performance materials. Lastly, in the automotive industry, the automobiles have a massive number of parts, many with complex geometries. Having the ability to create these parts with many fewer machines in one step of process can help car manufacturing save money. It helps automotive suppliers and companies develop consolidated and lightweight components that lead to more efficient vehicles.
Hi, my name is Louisa Qin, metric number B06211022. Today I will talk about importance, advantages, and disadvantages about hybrid manufacturing. So the key features of hybrid manufacturing includes ability to add material to existing parts. It allows to formatting up and repairing challenges damaged parts, only when needed to reducing material costs. It also cuts down on the amount of substitute machining work. The material is only added by needed, which reduces the area requiring additional finishing. It has the ability to switch between additive and subtractive operation without having to move the workplace. It brings significant time savings. So what is about the advantage of traditional hybrid manufacturing? It is a rare shape making ability. Additive manufacturing is very effective for unusual or complex component shapes that can be difficult to manufacture using other processes. It can combine assemblies into single parts because it reduces the overall product cost in unique situation. It does not have any tooling cost. With additive manufacturing, there is no tooling cost that benefit to a low volume production strategy. So this is about disadvantage of traditional hybrid manufacturing. It includes part cost. Metal additive manufacturing has its benefits in cost when unit of 1 to 100 prototypes. Surface finish. Additive manufacturing powder itself very rough compared to traditional powder materials. Dimensional control. The larger your design is, the more tolerant you must input. So these are the advantage and disadvantage of modern hybrid manufacturing. The advantage of modern hybrid manufacturing is flexible design. It allows for the design and building of more complex designs than traditional manufacturing processes. It also rapid prototype. It speeds up the prototyping process. It has a strong and lightweight parts, particularly important in industries because automotive and aerospace where lightweighting is an issue that can deliver greater fuel efficiency. The disadvantage of modern hybrid manufacturing includes limited materials. It can create items in a section of plastic and metals. The available selection of raw materials is not exhaustive. This is due to the fact that not all metals or plastics can be temperature controlled enough to allow 3D printing. It restricted build size. Sorry, you have a small print chambers will restrict the size of parts that can be printed. Post-processing. This is a form of cleaning up of post-processing materials from build and to achieve required finish.
Hello, my name is Lami Bibinda Lukadim and my metric number is B06211004. I will present about the key features to consider when comparing machines that provide hybrid manufacturing capabilities. So as we all know, hybrid manufacturing refers to the combination of additive manufacturing, which is 3D printing, and subtractive manufacturing, which is CNC machining, which is called computer numerical control processes within a single machine. Firstly, additive and subtractive processes. A hybrid manufacturing machine should offer both additive and subtractive capabilities, and it should be equipped with a 3D printing system for additive manufacturing and also a CNC machining system for subtractive manufacturing. The integration of these processes allows for a seamless transition between the two, reducing the needs for multiple machines. Second, the material compatibility. It should consider the range of material that the machine can handle for both processes and be capable of working with a variety of metal, polymers, ceramics, and composites, depending on your specific requirement. It is to ensure that the machine can accommodate the material you intend to use for your application. Third, build volume and machining area. It is to evaluate the size of the build volume for 3D printing and the machining area for CNC operation. The machine should provide sufficient space to produce your desired part within the required dimension. It is also considers both the maximum part size and the available workspace for simultaneous additive and subtractive processes. Next, accuracy and precision. It assesses the machine's accuracy and precision for both additive and subtractive operations. Look for features like high resolutions, 3D printing capabilities, precise CNC machining tools, and advanced control system to ensure the production of accurate and dimensionally accurate parts. Next, automation and software integration. It is about checking for automation features and software integration to streamline the hybrid manufacturing process. Look for features like automated tool changes, robotic material handling, and advanced software interfaces that enables seamless transition between additive and subtractive processes. Moreover, workflow and process control. It considers the ease of use and process control capabilities of the machine and look for features like intuitive user interfaces, advanced process monitoring systems, and closed-loop feedback mechanism to ensure quality control and repeatability throughout the hybrid manufacturing process. Moreover, scalability and modular design. It considers the scalability of the machine and whether it allows for future expansion or customization. A modular design enables the addition of new features or process capabilities as your manufacturing needs evolve, providing flexibility and investment protection. Next, the support and service. It evaluates the manufacturer's support and service offerings. It also considers factors like training, technical assistance, availability of spare parts, and the manufacturer's reputation for reliability and customer satisfaction. Last but not least, the cost and return on investment. Finally, consider the overall cost of the machines, including the initial investment, maintenance, materials, and the operational expenses. It assesses the potential return on investment based on your production needs, the complexity of parts, and the benefits of integrating additive and subtractive processes. Thank you.
My name is Nurubakis Binta Razak. My metric number is B0621101138. Number 4, let's explore a potential application of hybrid manufacturing prior to the current production method processing, a core part and common in the automotive industry. Step-by-step explanation of hybrid manufacturing in automotive production, BMW. Step 1. Design and CAD modeling. To design the automotive component using computer-aided design CAD software. The design is characterized on the required specification and performance criteria. BMW used the lot system CAD-IA as the main CAD solution, generally in its V5 version. CDM V5 enabling engineers to streamline the improvement process and gain efficiency in managing verification tasks, ensuring high-quality 3D prototypes. Step number 2, additive manufacturing 3D printing. In the hybrid manufacturing process, additive manufacturing techniques are using to create the internal shape of the part. The types of 3D printing method by BMW is describing selective laser brain melting (LBM) or selective laser sintering. Involves a layer-based process of melting a powder, which is then frozen by a laser pump before more layers of powder are applied at the basic platform is lowered after as passed. Step number 3, subtractive manufacturing machine. Once the internal shape is 3D printing, the part undergoes subtractive manufacturing process. The involver using traditional machining technique like milling, turning, or grinding to remove excess material and refine the dimension of the parts. CNC, computer numerical control machine, are commonly used in the step to precisely shape and finish the component. BMW tooling engineer can use source-matrix CNC machine, 3D printing, and external casting for custom assembled factory, which allow the company to put the finishing touches on its release quickly and cost-effective. Step 4, post-processing and finishing. After the subtractive manufacturing step, the part may require post-processing and finishing operation. These could include processes such as hard treatment, surface polishing, crafting, or painting to enhance the part's machining properties. Aesthetics and corrosion sensitive. The engineer, transmission, atlas, and its whole system are perfectly conditional, ensure a seamless driving experience. The various performance relies on this component, ensuring it does move on if out of track. The last part, BMW is standard and the engineer is started for the first time after may test the new various come off the line. Step number 5, quality control and testing. The finishing part goes test recursion quality control measure. BMW conducts determinational inspection, material testing, and functional testing to ensure that the part meet the required specification and standard. This includes changing for dimensional accuracy, mechanical strength and compatibility with other components.